Good day, everyone. I am Karen Nocum, a PhD Math student at DLSU University, Manila. My presentation is on stability analysis of the pyramiding game. This work is under the supervision of my advisor, Dr. Ederlina Nocon. As a background of the study, evolutionary game theory models interaction between species in a given population over a period of time. It focuses on the properties of the whole population and not only on the decisions of an individual player. Basically, EGT was first applied in the context of biology, and it has now been an interest with economists, sociologists, social scientists, and game theorists, and etc. But majority of the papers in EGT was assumed to have simultaneous action in nature. So this motivates us to formulate or define a new game called pyramiding game, which is sequential and asymmetric in nature. In this pyramiding game, we have two sets of players. Players I sub i's and players j sub i's. So the game follows a sequence of decisions starting with player I sub 1. Each player I sub I will then decide whether to invest in low risk, that is LR, or in high risk, that is HR investment. If I sub I will choose LR, then there are players J sub I's who will then decide whether to accept or not the offer of I sub I. At each step, every deciding player has its corresponding cost of investment. So the game will reach the stopping point T provided that I sub I will choose HR investment. At the stopping point T, we can actually compute for the payoff of the game or payoff of each player by considering the accumulated cost of investment plus the additional reward given to them. And take note that players can invest based on their available resources and on their target reward. So that is how we define the pyramiding game. In this paper, the focus of the study is on the strategies employed by ISA-1 type of players on a large population. Our aim is to determine the stability of the equilibrium points computed in the system of differential equations by using the linearization technique and the Hartman-Grobman theorem. So here, we let N and M be the population of I sub 1 and I sub 2 type of players. So for an even stopping point T, we let the proportion of population N be X for those players who choose LR and 1 minus X for those players who choose HR. For the proportion of population M, we let Y be those players who choose LR and 1 minus Y for those players who choose HR. Similar interpretation for an odd stopping point T. So, based on the defined payoff of the game, we can actually construct the payoff matrix of the pyramiding game gamma depending on whether the stopping point T is odd or even. And using the concept of replicator dynamics, we can come up with the following replicator equations. And from here, we can compute the corresponding equilibrium points when T is odd or when T is even. From these computed equilibrium points, our aim is to determine which among of these points is stable or not. So we come up with this result. So for the pyramiding game gamma, the only stable equilibrium point is when x is equal to 0 and y is equal to 0. That is if the stopping point t is even. So for the proof, we use the concept of the linearization in the Hartman-Grobman theorem. So this result means that all members of the population, either of type I sub 1 or type I sub 2, they should choose HR from the start of the investment until the stopping point T is reached. Also, this implies that players of type I sub 2 will just imitate the choice or strategies of type I sub 1 players until the end of the game. So in reality, this result suggests that or says that individuals tend to imitate the strategies of those successful person in order for them to be successful as well. So that is why investors should invest until the end, given that their resources are enough and have reasonable returns. Thank you very much.